Okay, hello everyone. We've got section R3 here today to start off with, and this is going to be about real numbers and their properties. So first of all, we've got the real number line, and this is just a nice visualization of what real numbers actually are. And of course, it's going to include all of our whole numbers, the typical 1, 2, 3, 4, what we're counting with, right? We've got 0 here in the center, positives to the right, and negative values to the left. Now these number lines, they don't have any endpoints. On the right, we're going to go off forever and approach positive infinity. The numbers are just going to keep getting larger. We're going to approach positive infinity. On the left side, the numbers are going to keep getting smaller, and we're going to be approaching negative infinity. Okay, now real numbers are more than just your typical positive and negative values. We can also include decimal values. For example, 1.5. This is going to fall right in the middle between 1 and 2. That's a real number. Something like negative 0.25, also a real number. All right, this is the equivalent of negative 1/4 or a quarter. You can even represent these in as rational numbers in a fraction format. Negative 7/2, which is the same thing as negative 3.5. That's also a real number. And finally, you can even have numbers like 3.33 with this line here. This means repeating forever. So this is a number that doesn't even terminate. It just goes on forever with all these decimals. This is also considered a real number. Okay? So the next thing we're going to talk about is how do we consider the order of these values? And we have two different ways of doing that to start off with. We can say something like A is less than B with this symbol here. It looks like we're kind of pointing off to the left. Or we can say that A is greater than B as if our arrowhead is off to the right. Okay, so let's look at some examples here. We've got negative 3 and 5. How are these two going to be related? Well, if we look at our number line here, negative 3 is going to be to the left of 0, right? It's smaller than 0. 5 is obviously going to be greater than 0. It's to the right side. So that makes negative 3 a smaller number, right? Because as we go to the left, the numbers get smaller. This is a smaller number than 5. So we can say it's less than 5. Then we've got negative 7 and negative 8. Well, if we draw these, remember, as we go to the left, right, we're kind of counting down this way, and the numbers, it seems like they're getting larger, but negative numbers are actually smaller, right? So negative 4 is actually smaller than negative 1. And in the same way, negative 8 is actually smaller than negative 7. But we're going to go off of negative 7 here. So is negative 7 greater than or less than negative 8? Well, it's greater than negative 8. It's on the right side. So we get larger as we go to the right side, smaller as we go to the left side. And finally, we can have a comparison between numbers like this, between 9/2 and 3/46. So remember, 9/2, we can represent this as something like 4.5. This is a number that might be a little bit easier to reason with. If we were to plot 4.5 and 3/46, well, obviously, we can see that this is a much smaller number than 3/46. So we're going to put that as less than. Okay, so those are some basic examples to start off with. Those are not the only kinds of inequality symbols that we have. Inequalities meaning anything other than an equal sign. Okay. So the next two that we're going to talk about here, consider are less than or equal to. So now it's the same kind of symbol as less than, except you've got this extra line underneath it. And the same thing with greater than. It's the same symbol as greater than, but now you've got this extra line underneath it. So this is going to denote equal to. So it's less than or equal to, or greater than or equal to. Okay, let's look at a couple of examples here. Let's see if these are true or false. The first one says -9 is less than or equal to 0. Well, if you go back to your number line, -9 is going to show up to the left of 0. So indeed, it's either less than or equal to 0. In this case, it's less than 0. So that works out. So that's true. Is 14 less than or equal to 0? Well, no, 14 is going to show up on the right of 0. That's false. Is -81 greater than or equal to -9? If we were to plot this, -81 is going to be way off to the left of -9. So it's not greater than, it's much smaller, or less than. So that's false. Is 89 greater than or equal to 9? Yes, of course, that's true. 89 is more than 9. Sorry, 81 is more than 9. And then the last one, we have the statement 81 is greater than or equal to 81. That's true. They're the same number, but because of this equal to component, this statement's true. 81 is equal to 81, and we're saying it's either got to be greater than it or equal to it. And in this case, it is, in fact, equal to it. So this is a true statement. Okay. Now we're going to talk about the absolute value. So the absolute value tells us a real number's distance from 0. How far away is this real number from 0? Okay, so if we wanted to take something like the absolute value of 4, well, this is 1, 2, 3, 4 spaces away from 0. And that doesn't matter if it's 4 spaces to the right or 4 spaces to the left. We don't care. We just care about how many spaces away. We're just counting. So this is 4 spaces away from 0. The absolute value of 4 is 4. The same thing is true for -4. Okay, this is 1, 2, 3, 4 spaces away from 0. We don't care that it's to the left this time. We're just counting how many spaces away it is from 0. So the absolute value of -4 is also 4. How about the absolute value of 0? How far is 0 from itself? Well, it's not, right? It's right on top of itself. It has no distance. There's no spaces away, so it's 0 spaces away from itself. So the absolute value of 0 is 0. You can consider even the absolute value of something like -5/8. Now, we already saw that for a negative number, its absolute value is just that number without the negative sign. The same thing is true for fractions. So -5/8 is 5/8 of a space away from 0. And even a number like pi. Okay, so pi is roughly the equivalent to 3.14, and it goes on forever. It's an irrational number, but it's still a real number. Its absolute value is itself. It is pi spaces away from 0. Okay, as far as operations go, let's think about division, which is really just multiplying in disguise. When we're dividing something like 12 over 3, all we're really doing is multiplying 12 by what's called the multiplicative inverse of 3, which is 1 over 3. Okay. Now let's consider division with 0 specifically before moving on. So, as we know, we can't just divide a number by 0. It doesn't have a meaning in the sense that we're used to. So if you had something like a over 0, we call this undefined. On the other hand, if you're dividing 0 by a number, in which case, right, a here is given to be not 0, it's any other number, -1, 346, whatever it is, it's not 0 in this case. 0 can be divided by any number with no problem. It's just going to give us 0 back. So 0 divided by 5, 0 divided by 800, whatever it is, it's still 0. However, if we had to divide 0 by itself, we call this indeterminate. We can't figure out what it is. The reason for this is if we had a number, say n, we multiplied it by 0, this would give us 0. If we went ahead and tried to divide both sides by 0 now, well, 0 divided by 0 can be anything, because n could have been anything. It could have been 5, it could have been 5,000. We don't have enough information here to figure out what that number is. So for this reason, we consider 0 divided by 0 to be indeterminate in value. Okay, so next we're going to come over here to talk about exponents. This is when we're raising a number to another number. So first we've got here a and n. We're going to read this as a raised to the nth power. A is what's called our base. N is what's called our exponent. And all this really means is that we're going to multiply a by itself an n number of times. Okay, so let's see what that looks like. So say we had 2 raised to the third power. So 2 is your base. It's the thing we are multiplying by itself. So we're going to just keep multiplying 2 by itself. The exponent here is 3. That's going to tell us how many times we're multiplying 2 by itself. So we're going to multiply 2 by itself 3 times. 2 times 2 times 2, and that's going to give us 8. This is also written as 2 to the third power. Okay, so if we come over here, we look at some examples. We've got 4 raised to the third power. That's going to be 4 times 4 times 4. That will give us 64. In the second case, we've got negative 6 in parentheses squared. So what this really means, the base is negative 6. We are multiplying negative 6 times negative 6. We have 2 of them here. Negative times a negative is going to give us a positive value, so positive 36. Now in part C, we've got negative 6 raised to the second power, but no parentheses. So what this really means is this negative is outside, right? This negative sign is not being raised to the second power. So how we can think of this is actually negative 1 times 6 squared. So it's 6 alone that's being raised to the second power, not the negative. So this is negative 1 times 36, and that's going to come out to negative 36. Part D, we've got 4 times 3 raised to the second power. That 4 is not being raised to the second power, only the 3 is. So we can kind of expand this out. 3 raised to the second power is just 3 times 3. So we've got nothing special here, just 4 times 3 times 3, which is going to come out to 36. Now in part E, it's a little different. Now we've got 4 times 3 within the parentheses. Both of them are being raised to second power. So the way we can look at this is we can simplify what's inside of here first and then raise that product to the second power. So 4 times 3 is 12. We can think of this as just 12 squared. 12 times 12, which is 144. Okay, and this is going to lead us into our next point a little bit, which is the order of operations. Now, hopefully everybody remembers that this goes by PEMDAS. So we've got parentheses, exponents, multiplication, division, addition, and subtraction. And these kind of operate in tiers, so to speak. So parentheses always comes first. That's what we do first. It's what we look at first. We simplify whatever's inside of parentheses first before looking at anything else. The next tier is going to be exponents. Once we've simplified whatever's inside the parentheses, we're going to raise them to their respective powers. The next tier is multiplication and division. Okay, so it's not that multiplication always comes before division. We're going to do whichever one comes first from left to right. And we're going to see how that works in a second. And the same thing is true here. So this is our last tier, addition and subtraction. It's not that we always do addition before we do subtraction. We're going to do whichever one comes first from left to right. So let's look at some examples here. A has 6 divided by 3. So we've got division. We've got an addition here, plus 2 raised to the third power. That's an exponent. And then finally, we've got multiplied by 5. So according to our PEMDAS, we're going to go ahead and we're going to do exponent first. So we're going to leave everything else the same. 6 divided by 3. 2 raised to the third power is 2 times 2 times 2, which is going to be 8. Okay, and that multiplication stays as it is. So now we've got a division, we've got an addition, we've got a multiplication. We're going to do the division first, right? So our next tier is division and multiplication. We're going to do whichever one comes first from left to right. So that division's coming first, so we're going to do 6 divided by 3 first. That's going to give us 2, plus we've got 8 times 5. So we've got addition and multiplication. We're going to go ahead and do that 8 times 5 next. We've got 2 plus 40, which comes out to 42. In our next case now, we've got parentheses to consider in example B. Parentheses comes first. Inside the parentheses, we just have an addition. Then when we go back outside, we've got a division, we've got a multiplication, and we've got a subtraction to consider. I'm just going to give myself a little bit more room over here. And we're going to dive into this. So we're going to look at the parentheses first. We want to simplify whatever's inside. And inside the parentheses, we just have 8 and 6. So we just add those together. We're going to get 14. Now we still have a division by 7. We have a multiplication by 3. We've got our subtraction by 6. And I actually don't need these parentheses anymore, right? So I've simplified whatever was inside. I've done that job already, so I can drop the parentheses now. So now we consider multiplication and division. We're going to consider whichever one comes first from left to right. Division comes first. 14 divided by 7, that's going to give us 2. Multiplied by 3, minus 6. So I only have a multiplication and subtraction left. Of course, I'm going to go ahead and do that multiplication first. I'm going to get 6. We're left with 6 minus 6, which is simply 0. All right. Now we're going to consider order of operations inside of a rational expression, which just means basically there's a big division bar. It's a big fraction. So the nice part about this is we can kind of consider the numerator and the denominator separately. We're going to consider them individually, and then we're going to worry about combining or simplifying at the end if we have to. Okay, so in the top, I've just got an addition and I've got an exponent. On the bottom, I've got a subtraction and a multiplication. And of course, I got that big division bar in the center. So on top, we'll do our exponent first. 3 raised to the second power is 9. In the bottom, if I'd like, I can go ahead and simplify this too, kind of laterally. I'm going to leave that subtraction alone. I'm going to do the multiplication, which is going to be 5 times 3. It's going to give us 15. Now I only have an addition up top. I've just got a subtraction on the bottom. And the division in the center. 4 plus 9 is just 13. 6 minus 15 is going to give us negative 9. So I'm left with 13 over negative 9. I don't have to divide those if it's not being asked for. This is already an otherwise simplified fraction. We do not have to put it as a mixed number or a decimal if it's not required. The only thing I'm going to do is I'm just going to write this as negative 13 over 9 with the negative out front. So remember, so if we have a negative in a fraction, just one negative sign, we could have negative a over b, a over negative b. Both of these are the same as just negative the whole thing, a over b, right? So that negative is going to come out front. It doesn't matter, they're all equivalent, but this is just how I'm going to be writing it for our purposes and how you might see it in a book or problems and homework or on an exam or something like that. Okay. Now the last one, again, we've got this rational expression. Let's slide this over a little bit to the left. We've got parentheses, but there's no operation inside the parentheses other than -1 times 3, which is just -3. Right? So this parentheses really isn't telling us to do an operation. It's just telling us consider this negative sign when you're raising this the third power. So that base is -3. So we're going to have to do -3 times -3 times -3. We're not going to drop that negative sign and bring it back at the end. We're going to include it in our multiplication. Same deal here. There's no operation to do inside this parentheses. We're just being told to understand this is a addition with a negative number. The parentheses down here, nothing. This is just simple signaling a multiplication and a multiplication. And we've got a little subtraction here. Okay, so let's go ahead and see how this looks. Well, let's go ahead and raise that -3 to the third power. -3 times -3 is going to be +9. And then I'm going to multiply that again by -3, so it's going to come out to -27. Let me leave that in parentheses because I haven't dealt with this negative yet. Okay. And then adding a negative number is just the same thing as subtracting by that negative, or by that number, I should say. Okay, and the bottom 2 times -8 is just going to give us -16. You can think of this as a negative number multiplied by a positive number. This will just be -15 left here. Okay. Negative times negative up here is just going to give us a +27. So we're left with 27 minus 5 on top, -16 minus 15 on the bottom. That's going to come out to 22 on the top, -31 on the bottom. And again, I'm just going to bring that negative sign up front. So our final answer comes out to -22/31. All right. Now let's look at what about when variables are involved. Okay, so let's see if we can evaluate each expression for x is equal to -2, y is equal to 5, and z is equal to -3. So what this means is we're going to have to go ahead and we're going to substitute these values in wherever we see these letters. So we've got -2 for x. We've got 5 for y. And we've got -3 for z. Okay. Now let's consider a PEMDAS. We don't really have operations inside of parentheses, but we do have an exponent here to raise first. And then we've got some multiplications, and then finally addition and subtraction at the very end to worry about. So -2 raised to the second power is going to give us a +4. Everything else pretty much just stays the same. Now let me go ahead and simplify this. So -4 times 4 is going to give us a -16. -7 times 5 is going to be a -35. And finally, 4 times -3 is going to be a -12. Go ahead and combine like terms now. We just add and subtract straight across. In this case, just subtract straight across. This is going to come out to -63. All right. All right, so let's take a look at part B. So we've got the same values here. We've got a rational expression. So we're going to start off with x is equal to -2. We're going to plug that in first, in here in parentheses. We've got y is equal to 5. And then we've got down here z is equal to -3. We're going to add that to 4. All right, so we're going to start off with simplifying the operation inside of our parentheses first. So that's -2 minus 5. That's going to give us a -7. And I'm just going to leave everything the same for a second. Okay. In our next step, okay, let's think about raising this -7 now to the second power. So -7 times itself, or -7 squared, is going to give us 49. And if we like, well, now we can also multiply this. We can just leave it the same for a second as well and do all of this in the next step. So I'll just keep it simple. So we've got 2 multiplications and an addition in the top. 2 times 49 is going to come out to 98. 4 times 5 is 20. So I'm left with an addition on the top and addition on the bottom. That's going to be 118 on the top, and negative 3 plus 4 is the same thing as 4 minus 3, which is just going to be 1. And 118 divided by 1 is just itself. Okay. And then finally we've got our last example. So now we've got fractions within fractions. Okay, so x is going to be equal to negative 2. That's divided by 2. Y is just going to be equal to 5, and it's divided by 5. Then we've got 3 times z, z being negative 3. All of that is divided by 9. Then we've got 8 multiplied by y, which is 5. All of that divided by 5. Okay. So let's see what we can simplify. Well, negative 2 divided by 2 is just going to be negative 1. And 5 divided by 5 is just 1. Okay, so we have a division here, and a subtraction. So the first thing we're doing is we're doing those individual divisions. And remember, with these complicated fractions, we can kind of just treat the top as a separate operation first from the bottom before worrying about that big division in the center. Now on the bottom, we can do 3 times negative 3, which is going to give us negative 9, divided by 9. Then we've got 8 times 5, which is 40, divided by 5. Okay, so let's see what that leaves us with. Well, negative 1 minus 1 is just going to give us negative 2 up top. Negative 9 divided by 9 is going to be a negative 1. And 40 divided by 5 is just 8. So this just leaves us with negative 2 over 7. And that's it. Okay, so that's applying PEMDAS within some relatively complicated looking fractions. But that's about it for R3.